Thank you very much for the invitation. I'm very glad to speak to you about my recent book, which is a popular account of work I've done in the past. The book is titled Next Civilization, and it's about network effects for sustainability, prosperity, and peace. Now, talking about civilizations, many of us, of course, are thinking of the famous book of Huntington, The Clash of Civilizations, right? So he basically suggested that we would see that clash, and actually, in a sense, it's ongoing, right? So that's something we have to ask, is it inevitable, or should we actually think about civilizations in a different way? So some people see this clash happening between the USA and China, or the East and the West, or North and the South, right? And there are, of course, many books also in that connection describing political strategies, even seeing the world as a grand chessboard. And that is basically the perspective that has been around in the United States for some time. And of course, there's also an equivalent, in a sense, in the Eastern world. Maybe the most famous book of this kind is The Art of War. But I'd like to say, I think we are wasting time on these kinds of conflicts. You know, had we invested the money that we have actually used for wars in the past 20 years into building a better world, you know, we would probably be living in a paradise already. I mean, it's really way more than 50 trillions of US dollars that have been used for war. And that's quite a lot of money, right? And I'd like to point out that, in a sense, the art of war has been replaced by the art of survival, and almost everywhere, in fact, not only in connection with the corona crisis, but also in connection with the sustainability crisis of the world, because we are overusing resources. And as a result, we see all sorts of bad side effects, such as climate change, financial, economic, and spending crisis, conflict and war, and mass migration, terrorism, and so on. It's so bad that some people even suggest that we would have to learn to die in the Anthropocene. That means in the age we're living right now. And some people think actually this is already ongoing, because in many countries we're seeing people triaged. That means they're life-death decisions taken by doctors, sometimes even supported by algorithms or apps in a data-driven way. And often this is also being put into the context of the so-called trolley problem, an ethical dilemma that asks the question, if not everyone can survive, who would have to die? But is it really true that China or the USA or some country or religion is our enemy? Or isn't perhaps outdated thinking our true enemy? And here I would mention in particular utilitarian thinking, because utilitarianism and optimization, in a sense, neglect all goals but one. Optimization requires one-dimensional comparisons. And I think that is overall implying pretty bad things for the world. We'll go into this later on. I do even think that is really one of the cores of many of the problems that we have today. So are we really faced with the trolley problem? That question needs to be asked, because really 1/3 of the world's food is wasted. So would people have to die of hunger? Is it really true that there is not enough for everyone? And many people would say, for sure, we have a logistic problem. The food doesn't always arrive at the place where people are in need. And same applies to other resources. And it's also a cooperation problem. So maybe the next civilization will be characterized by overcoming competitive greed and going towards a more cooperative system, a circular economy and sharing economy. And I will come back to this later on. So what I'm proposing is that now we are living in a highly networked world that is changing everything. And we should actually use network and feedback effects for the better. In fact, network effects can make a huge difference. We are now experiencing, I believe, a transition from a component-dominated to an interaction-dominated world. And we can use combinatorial innovation in order to boost our economy. We can use collective intelligence to support our society. And we can use multidimensional real-time feedback support to support nature. And so I'd like to illustrate the wonder of feedback effects with an example that some of you may know already. This is about traffic flow. In fact, on all freeways of the world, most likely you're seeing these undesirable traffic jams sometimes. Stop and go waves are illustrated over here as we see them many times. This is a computer simulation based on mathematical models and illustrates that we understand the main features of the process. Now, if you want to see what is causing the stop and go traffic, we should take a helicopter or a drone and it will give us an overview. And so we see that there is an on-ramp where cars are trying to sneak into the freeway, which produces small perturbations in the traffic flow. And those small perturbations are being amplified by something like a domino effect. Now, suppose we equip a certain percentage of cars with radar sensors, for example, that measure the distance and relative velocity and allow to drive those cars in an automated way, slightly differently from drivers. And as you can see over here, this allows us to overcome the traffic jam. And so what we have done basically is we have made real-time measurements and introduced real-time feedback to change the interactions between cars slightly. There is no traffic control center that controls every car. We just change the interactions of some cars with the other cars, and that already can make all the difference. Because the inflow stayed the same, but we could get rid of the traffic jam, right? By stabilizing the traffic flow and slightly increasing the capacity by changing the interactions. And here you can see it really doesn't require every single car to be equipped with that technology. Already, when there's about 20 to 40% of equipped cars, according to that simulation, will have a massive impact, a massive improvement. And basically the traffic jam goes away, which means like the multiplication of the travel time can be avoided by avoiding the traffic congestion, right? So small changes in the capacity and in the flow of the system will have huge impacts on travel times. Okay, so all of that was reached in a decentralized way by just slightly modifying interaction based on real-time feedbacks, real-time information, right? And the question is, can we also apply that principle to other systems? And in fact, we have tried to do that for urban traffic flow. And here the situation is much more complicated, and that's what you often see. Now, I've been very fascinated by an observation that I've made in Egypt some years back, close to the pyramids of Gizeh, actually. There's self-organized traffic intersection. Highly diverse traffic participants, but most of the time they don't have to stop. There's no traffic light, there's no policeman, it just self-organizes. And the trick is the design of that intersection. We have unidirectional flow in the front from the left to the right. We have an opposite flow in the back, and in between a small buffer, which basically allows every participant to adjust the speed in such a way that there would be a gap just at the moment when you want to cross the road. So basically, the question is, using digital technology, could we basically go away from that over-regulation that the world is suffering from today towards systems that support self-organization? And here we have been inspired by oscillatory flows of pedestrians at bottlenecks. So that is happening based on a pressure principle. There's no policeman, there's no traffic light, there's no rule prescribing that oscillatory flow. It just self-organizes, right? And so the idea was we could maybe transfer that principle to intersections of roads where we would have more flow directions, but still intersections would be a bottleneck. And the hope would be that we would find a pressure principle that would create oscillatory flows and could be used to define traffic lights controlled by traffic flows. So that works very differently from how things work today, where we basically have a traffic control center in every city. And this one is trying to collect as much data as possible about the traffic situation. Then there's using a supercomputer to try to determine the optimal traffic light control and impose it on the entire city like a benevolent dictator. Just the issue is, traffic light optimization is actually NP hard. So it cannot be done exactly in real time. And so you need to simplify. And the question is, are you throwing away very good solutions by those simplifications made? The next approach shown in the middle assumes something that we could call a homo economicus approach. Here, every single intersection locally tries to do the best thing they can do, say to minimize travel times, considering only those cars in the neighboring road sections. So there is no coordination between intersections, and therefore we would assume that this cannot be as good as the thing that the traffic control center can actually do. And then on the right-hand side, we extend that by a further rule, namely that large queues of vehicles would first be cleared before we go back to travel time minimization. This is to avoid spillover effects. That means it's other regarding to neighboring intersections, but it goes away from the travel time minimization, and therefore we would think that's probably the worst of all solutions. But let's see what really happens. Now, the red line corresponds to what the traffic control center does, the top-down regulation, right? So as the capacity utilization goes up from left to right, we see that the queue length is also growing as expected, right? Now, how well is actually the homo economicus, the selfish optimization approach doing? And that's shown by the dashed violet line, purple line. And what you can see is, surprisingly, this is doing much better in terms of the queue length for small capacity utilization. So here, Adam Smith's invisible hand, self-organization really works well. But then there is a capacity beyond which the queue length is really exploding, and we can say Adam Smith's invisible hand unfortunately fails. And that's in fact, of course, the reason why we have traffic control centers, right, which cost us many millions every year. But surprisingly, the other regarding optimization approach that pays attention to neighboring intersections is doing better all the way. Now, this means that bottom-up self-organization, a decentralized optimization approach and coordination approach can outsmart optimal top-down control, quite surprisingly. And it can make the invisible hand work. But of course, all of that has been done for a theoretical scenario in a computer simulation, right? And so the question is, how well would that work in reality? And this has been tested for a scenario in Dresden. So we got in touch with the traffic authorities in Dresden and asked them to cooperate with us. And they said, well, we're actually altogether quite happy with what we have. So they just bought at that time a new traffic light control software, state of the art. But they said, there's just one area where we are unhappy, which is in the center of Dresden. This area, in fact, where we'd like to prioritize public transport. But if we do that, basically the green waves produced by the software have to be interrupted, and that causes traffic jams that quickly spread throughout the city. And so we quickly get a monster traffic jam if we prioritize public transport, because there's so many tram lines and bus lines cutting through this area that this was just mess up the entire system. And we said, okay, we'll try and see what we can do. And so we got data about real traffic flow. We simulated the situation, the current state-of-the-art control, and our flexible self-control approach. And you can see both of them produce green waves, but they look different. Like the one on top basically imposes a pretty regular green wave pattern, while the one on below, the self-control, flexibly responds to gaps in the traffic flow and is kind of adjustable to the situation. Now the question is, what works better, right? And now, surprisingly, our self-control approach, as compared to the state-of-the-art approach, is actually creating massive improvements for public transport, even some improvements still for motorized traffic, also a big improvement for pedestrians and cyclists, and of course for the environment it would be better as well. So the paradigm change to go from top-down optimization attempts towards a bottom-up self-control actually looks extremely promising. And then it took a few years until it was also implemented in a city in Switzerland, Lucerne in particular. And it was independently evaluated by a team of scientists at ETH, which, they didn't even contact me. And however, it turns out that this works extremely well, and they called it even the super traffic light, more green for everyone. Something that seems to be impossible, but basically means that we managed to use scarce capacities of space and flow better than state-of-the-art approaches could do. And that is something which also promises to be beneficial for logistics systems and many other systems, in fact. I mean, basically, it seems like we managed to do the impossible. Now, the question, of course, comes up, can you do better with artificial intelligence? And the answer is, well, it depends. So what you see over here, if we use a machine learning approach, like press light, the purple line, it takes pretty long to get to the performance of the analytical self-control approach that I presented before. And if you want to be better than that, in fact, you must feed in knowledge of that analytical self-control approach into the machine learning procedure, because otherwise it'll not get better than the analytical approach. If you combine those two approaches, however, you also save a lot of learning time and energy needed for the learning process, right? So the conclusion is that approach that we developed is also still important for the time of machine learning. And in principle, what I said before still applies to today, even given those powerful machine learning approaches. So we can basically conclude this example by saying the advantage of centralized control is large-scale coordination, but there are several disadvantages when there is a vulnerability of the network, if there's information overload, if you select the wrong control parameters, if you have delays in adaptive feedback, if you have a complex system with heterogeneous elements, large degree of fluctuations, short-term predictability, then a centralized control approach basically can be outperformed by a distributed control approach, and some autonomy and flexible response to local conditions actually is beneficial if you do it right. And that also has implications for the way our economy should be organized. And there is a paper about that. Now, the question is, does that only apply to traffic light control, or does it also apply to our economy? And I'll start with logistics and supply chains. In a sense, there are generalization of road networks. So road sections correspond to buffers in production networks, travel and delay times to cycle times, congestion to full buffers, and junctions to processing units, and so on and so on. And so they're equivalent to some extent, but production networks are more complicated because cars don't change as they drive from one place to the other, but products are being changed as they're being produced. Okay, so that's more complex. But we have been doing a couple of projects with some industrial companies such as Infineon Technologies, a chip producer, and they have been trying to improve the throughput of their production. And for this, they have tested a lot of parameter combinations corresponding to different treatment times of those different chemicals to those wafers, and have made measurements. And it turns out that if you slightly change the one parameter or two, you would get large variations in many cases of the throughput. So basically, whatever measurement you make, it's not predictive for any other parameter set, even close by ones. And in fact, they were far off the promised throughput of that system. So rather than 266, they produced only 150 wafers per hour. So there was a huge difference, actually. They were not using their machine well, and they didn't know what to do. They were trying to reduce those treatment times in the chemicals, and we proposed just the opposite. We said, try to extend treatment times to avoid a conflict of the use of that wafer. The wafer is the unit that moves, now the handler. The handler is the unit that moves around the wafers between those different chemical bases and water basins, right? And there could be different sets of wafers asking for handling at the same time. So there would be conflicts of interest. And we avoided those conflicts of interest by extending treatment time. So you would think that would reduce the throughput, but just the opposite was the case, because now we could coordinate those treatments in the different basins better. So an amazing 33% more throughput could be reached by that slower is faster effect. A coordination effect in principle. And we have also been looking into supply chains and generalizations. In those supply chains, because of delayed adaptation of production to changes in demand, there would potentially be bullwhip effects. And you can also have that actually in supply networks. And in a sense, the world economy is a supply network, a giant one. And so we have formulated equations for those supply networks and looked at what would be the behavior predicted for those different supply networks. And we found that there were 3 different possibilities: damped oscillations, overdamped behavior, growing oscillations. So those 2 behaviors, the damped behaviors, are leading to a kind of equilibrium behavior of the economy. But there could be those oscillations, also sustainable oscillations. And so we were looking into what was expected for the real input-output network of our world economy. And it turns out this produces oscillations, like the booms and recessions that you observe in the world economy. So we can understand that as a result of network effects. And then the question is, can we actually reduce those oscillations? Because they're very undesirable, very bad for the world. And we have compared different kinds of supply networks, supply chains, or that hierarchical network, or that supply that are in the middle here. And it turns out that produces very different dynamical behaviors. In fact, the system in the middle, the supply ladder with those alternative supply routes, that is dampening out those oscillations almost completely. So having those redundant routes is actually beneficial to stabilize those supply networks. And this is also what actually Intel technology does, probably based on the experiences that he made, but it confirms the theoretical implications of our model, which is quite interesting, right? We've also gone further than that and basically come up with an agent-based model of production, where each machine and each buffer is an agent that basically independently acts, but also interacts with other elements of the production system. And we could even run an evolutionary algorithm that would modify the layout of the factory and come up with improved layouts, more or less automatically. We were also going further than that by allowing the products to talk to machines through RFID chips, say, and also products to talk to other products. For example, if there was a late production of a certain product, it could tell the others, I'm late, please let me overtake. And so the production would kind of self-organize in such a way that there would be an improved performance according to the needs. Here is a funny example, by the way, of part of a production system which has to distribute packets to different areas. And you can see, as long as the load of the system is small, those packets just take the direct route, while if it's loaded, suddenly there will be a counterclockwise rotary service, right? So there's a self-organization process in the system. And that is something that we would like to use actually to produce a circular economy. That's basically why I showed you this example. And so how do we produce a more sustainable world? Well, basically, I think we need to have a participatory approach, and we need to have a multi-dimensional finance system, which we call Finance 4.0 or Fin4, in order to get from that situation, what we have today, supply chains, which are very wasteful, towards a circular economy. Because at the moment, every one of us in the civilized, so-called civilized world is producing 50 tons of waste in a lifetime. And that's quite a lot. And it includes a lot of furniture and cars and computers and smartphones and a lot of other things that can be actually reused and recycled. Just we haven't managed to get there because we couldn't enforce it efficiently by means of laws and regulations. So the approach that I'm proposing is quite different. It's based on the Internet of Things, which we propose to be used in order to build a global measurement system, actually participatory measurement systems for the people, run by the people. We've started to work on such a system. It was called NervousNet at that time. And the idea was that it would be able to measure externalities such as noise or CO2 or temperature or waste of all kinds, materials of all kinds, and good things, bad things. So externalities, in other words. And we would then combine that measurement with incentive systems, a multidimensional incentive system, in fact. So each measurement, each kind of measurement would basically find a different kind of currency. It would be multidimensional money. And we could create a multidimensional real-time feedback, incentive, and coordination mechanism in this way, trying to reduce negative externalities and trying to increase positive externalities. And such a system can now be built, for example, combining the Internet of Things with blockchain technology. And that comes down to introducing new forces into our economic system, forces that would reward more sustainable production, more social friendly production, engagement for culture, and so on and so on and so on. So basically, we would introduce, in a sense, a new coordinate system that allows for the coordination among those different elements of the economy, a co-evolution that would eventually lead to a sharing economy and a circular economy. And in fact, this book about the Finance 4 system will soon come out, hopefully in a few days from now. And the idea is that we would really have to go away from those typical supply networks of today, which are, as I said, very wasteful, towards systems which are much more like those that we find in nature. Because nature, in a sense, is a perfect circular economy. Everything is being reused. And those supply chains look very differently. There are circular elements in those systems. And yes, if you look at the ecology, if we look at our body, these are self-organizing complex systems, but they're not based on optimization, and particularly not based on the control by one quantity, like, say, US dollar or water, but there are many feedback cycles that control carbohydrate, proteins, vitamins, minerals, and so on. In fact, in our society, we have so many goals. Prosperity is just one of them. There's sustainability as well, health, education, culture, But optimization, in a sense, neglects all goals but one. Yeah, of course, you can come up with an index, but that is not the same thing as a multidimensional co-evolutionary process as we see it actually in the ecology, where there are many symbiotic effects. So we don't have a zero-sum game. Nature has basically been able to overcome, to some extent, limitations of resources by creating these symbiosis effects. And we're trying to create a similar system with that multidimensional money system that we've created. So that is something which allows to control complex systems much better, and even allow for the creation of self-organizing or self-regulating systems. That is really a paradigm change. With a multidimensional value exchange system, there are many more possibilities to find solutions that benefit all. The space of possible solutions is significantly increased, and that is also what one of my ideas is about, the interaction support processor, which is trying to do exactly this, create synergy effects and thereby overcome exploitation. In many cases, in fact, it's possible to turn win-lose situations into win-win situations. And that's something which, of course, should be or could be the principle underlying prosperity of the future. A system that would go away from the exploitation of nature and people towards mutually beneficial and supportive systems. And so basically that approach is bringing cybernetics and synergy together, but not to produce a centralized cyber system, but instead to engage principles of synergetics. And that is something we are recently learning a lot about. Biodiversity is actually something which is not only favorable from a philosophical or whatever point of view or ethical point of view, it's even increasing productivity. So plants are living beings that benefit each other in many cases, you know, at least certain kinds of communities of plants, they've learned to benefit each other. And we should learn on this planet to benefit from each other better without exploiting each other. And the same thing with other species and with nature. So we can learn a lot from how nature is doing it, and we can build new feedback systems that are enabling this new kind, new basis of a new civilization. We could also think about resilience, because the world will be challenged in the future by resource shortages and other challenges such as, you know, disasters, natural and other disasters. In many cases, those are based on cascading effects. A single small So you see, a single small perturbation can really mess up the entire system. As that has happened in many blackouts, or also in the financial system, where the bankruptcy of Lehman Brothers caused the bankruptcy of hundreds of banks, losses of hundreds of billions of dollars. And in fact, you know, the financial and economic crisis hasn't really stopped since. We are still in trouble. So we can say networking is good in many cases, but it can also promote cascading effects, and we need to learn to build resilient systems that are able to stop those cascading effects, but also can quickly recover from surprises and disasters. And that requires basically principles such as redundancy, diversity, decentralization, modular design, distributed control, subsidiarity, and digital assistance. And in fact, while this was yesterday's survival kit, in a sense, our smartphones can be today's survival kits, right? They have so many sensors in them, and they can be used actually to help us in all sorts of situations. For example, to detect earthquakes, to warn our friends, to get into a safe place in time, to map crises, such as UN OCHA has shown, to build our own ad hoc networks between the devices if the public communication system has broken down. And in fact, we've shown how to improve those systems recently based on the principle of fairness that actually allows us to extend the time those ad hoc networks work beyond a period of 3 days, which is the critical time period after a disaster strikes, and could therefore largely support the survival of people and help them help each other. Now, in the kind of times we're living, freedom also, I believe, is an important principle. Big data and also artificial intelligence, in a sense, runs on the data of the past. That means it doesn't include future solutions, such as innovations. And optimization can improve systems, but it's not enough to save the people of the world in the situation we're in. We need innovation. And innovation actually benefits from freedom, as we can see in an analysis of where new ideas are actually born as compared to where they're primarily consumed. So if we use artificial intelligence to control systems, we shouldn't over-control them in the sense that we're eliminating all degrees of freedom. We should automate those situations which are clear cases, what to do or what not to do, while those cases which are kind of borderline deserve some deliberation by human beings. And so we should basically design for free choice, in particular if a decision is about an important issue, such as friendship or love or marriage or the choice of a job, for example, or a life-death situation, as it happens in triage situations, right? So I don't think we should leave such things to an algorithm and automate these kind of situations. Now, however, if everyone starts to be creative and innovative, of course, we need to have a coordination mechanism that creates interoperability in a highly diverse world. And this is actually where this interaction support processor really comes in and can help to serve as a social adapter, also as a social protector, or create awareness of the situation we're in and the impact that our actions is causing to the world. But we could certainly solve the problems of the world in two ways. One would be in a hierarchical top-down way, like the military does it basically, or we can do it in a participatory way, as you can see it on the bottom right, where everyone is saying what they need and everyone is saying what they can do, and there would be a matching platform, such as Helping Hands, for example. I was one of the tools that was developed at this hackathon on earthquake resilience that I mentioned before. Also, when it comes to cooperation problems, it's often claimed that we need centralized control because there are those tragedies of the commons where coordination or cooperation fails and produces bad outcomes such as environmental exploitation or pollution or tax evasion, destruction of all kinds. But it turns out, and actually Nobel Prize winner Elinor Ostrom has shown this, self-governance is actually efficient given proper design principles. And she has in fact formulated 8 principles for the management of common pool resources, which work quite well. And there's a lot more work in the meantime on such self-organization principles. So we don't need centralized control to produce a cooperative outcome in a social dilemma situation. In fact, we've been looking into some of those mechanisms, and over here we have a system where there are 4 different behaviors. Cooperation or defection, think of climate change, for example, and certain kind of behaviors connected to climate change. But you could also kind of punish people who don't behave, or countries who don't behave cooperative. These are called moralists, and then there would be immoralists to punish others who don't cooperate, even though they don't cooperate themselves. So that's why we call them immoralists. Okay, so 4 different behaviors, and if everyone in such a system would interact with everyone else or with randomly chosen partners, that leads to a tragedy of the commons, as I showed it before, where in the end you have defection basically by everyone. Now, interestingly enough, if you have those 4 strategies interact in space with the neighbors, and everyone imitates the best performing strategy, then you find a completely different outcome after some time. In the beginning, actually, it looks also like you would end with a defection, but then eventually you find some segregation effect of those different strategies, which is beneficial for an outcome where in the end almost everyone cooperates and punishes non-cooperative behavior. And here you can see it actually, how it evolves over time. So red is defection, blue is cooperation, green is moral behavior. And that is what finally dominates. Now the question is, do you need punishment to arrive with cooperation? And the answer is actually no. There are other mechanisms that also support the emergence of cooperation, such as altruistic signaling, for example, or merit-based matching, where basically the more cooperative people or countries are matched with more cooperative people or countries. That creates a tendency towards more cooperation altogether. Quite interesting mechanism, certainly practically useful. And the question is, how could we actually support peace? And here's a system that we have actually studied for some time. It's a system where everyone basically competes with their neighbors. And I wanted to know, do we really end up with the so-called homo economicus, like selfish people who exploit everyone else? And the answer is, well, for most parameter combinations, but not always, because also you could have the evolution of Homo socialis down here, if the offspring, the children, are raised in the neighborhood of people, which of course they do for a pretty long time, say about 80 years long. And that is a condition that really promotes the emergence of other regarding preferences and network thinking. However, it takes a couple of dozen generations to get there, right? Then suddenly you have an outbreak of friendliness or fairness. And that also promotes the superiority of cooperation as compared to defection. So if you just wait long enough, then basically worlds in which everyone is selfish will turn into a world where everyone has some preference for paying attention to others, some friendliness, say 40%, almost like love your neighbor as yourself. And that is actually beneficial for everyone, right? So in a sense, we can understand now why Adam Smith actually has reported that observation in his book, The Theory of Moral Sentiments, where he wrote, however selfish man may be supposed, there are evidently some principles in his nature which interest him in the fortune of others and render their happiness necessary to him, though he derives nothing from it. So people do have some other regarding preferences, which you see also in those experimental results down here, where most people actually have some degree of pro-social preference. And that evolution will also lead to a cooperation between strangers eventually, as those snapshots over here show. Now, let's look at another problem that we often face, is that of convergence, you know. So, you know that book of Edward Bernays, right? How to Manufacture Consensus. And he describes how to do that through propaganda. That means manipulation of opinions. And that's actually a principle that's being applied today, not only by autocratic systems, but also by democracies. And public policy uses that kind of approach quite a lot. And it's also part of modern war fighting, just that everything became personalized, you know. So the military knows you exactly, in a sense, you know, they have digital avatars about you and they can target you. And actually many advertisement companies can do that as well. So we're being manipulated by modern propaganda tools, which are highly personalized and which are changing our behaviors. But do we have to do that? I mean, it doesn't seem to be really fitting well to the idea of democracy. And here we have described a different perspective, how to make democracy work in the digital age, where we describe how to create collective intelligence by massive open online deliberation platforms. And see, here is another title, Taiwan is making democracy work again. So kind of a similar title. And what they've done is they've used artificial intelligence systems to match people with different opinions on a certain subject, to have them figure out together a solution that satisfies the interests of both sides. And through repeated interaction, that is actually creating a consensus process based on public democratic deliberation. And once that consensus has been reached, that is basically put into law. So today, in other words, we can have other principles to form consensus, which is based on democratic deliberation process, and basically is harvesting principles of swarm intelligence. I mean, the idea is pretty old, right? I mean, already in 1714, there was the fables of the bees. And in principle, the suggestion was that society could be organized like a beehive. And in fact, beehives self-organize. There's not a queen bee that tells everyone what to do. It just lays eggs, basically. And everything else is based on self-organization. In fact, these kind of swarm intelligence processes have been studied quite a bit, and it turns out there are basically three phases. There's first an independent exploration phase, and here diversity is important, and people or species shouldn't be manipulated in their exploration process. Then phase two, information exchange, communication. And then phase three, integration, and eventually decision making. And that's something that we can learn from. And in fact, we can use it to create a wisdom of crowds effect. And it has been studied in many papers. In fact, there's this paper also in Science that shows that diversity is highly important in order to create outcomes that are better than any expert actually could create. So this is really about bringing the best ideas of many minds together and to combine different points of view in an online deliberation process that would integrate different solution approaches in an innovative way and come up with solutions that work for many. That means, in a sense, diversity wins and not the best. And that can be supported by certain kind of incentive systems, as we've shown. And that means if we build sufficient platforms, certainly not Facebook or Twitter, then we could actually support the creation of collective intelligence, right? Also, if the consensus doesn't happen by itself, then there would need to be a decision-making process. But there are also different ways of doing that. So you can, of course, engage in a majority voting process. But there are many other voting processes, and some of which are much better, actually, than majority voting, and take on board minority opinions better to improve the overall outcome for more people. And I think this is what digital democracy should be about, creating collective intelligence. Now, the question is how to save the world, so how to scale it up to a global scale. And here we believe that the activities should be centered on cities and networks of cities. And in fact, we could engage in city Olympics or climate city cups or city cups of all kinds. So basically, this would be a competition of cities that combines not only that combines actually competition with cooperation, in the sense that there would be different disciplines to compete in, like reducing climate change, increasing energy efficiency, enhancing resilience and sustainability, promoting solidarity and peace. These would be different disciplines in which those cities compete, small cities with small cities, big cities with big cities. And then each city, with all the stakeholders engaged, that means businesses, universities, the media, politics, and the citizens, first of all, they would come up with new solutions and the implementation of new solutions. And then there would be a best of list as the outcome of that competition between cities. And those solutions would be open source or Creative Commons. such that the solutions can actually be developed further and upgraded and combined with each other. And this is how actually collective intelligence can be boosted globally to the benefit of all cities and all citizens. So that would be a new paradigm of globalization that we call localization, which is based on thinking global, but acting local and diverse. It's based on experimenting, on learning from each other and helping each other. And actually, it's not that difficult. There are already some cities who are engaging in make city festivals, which engage citizens to improve their city in many places. And we could do that in many cities at the same time and then exchange the ideas and the solutions and combine them and help each other, as I said before. So why don't we do that? Why do we wait for the United Nations? Why do we wait for global corporations? Why don't we take control of our cities to some degree? Because we want to co-create our future. We want to have an impact on the cities we're living in. So the success principles of the future civilization, I think, would be co-learning, co-creation, coordination, cooperation, and co-evolution. And actually, we could imagine to engage into a global project called Culturepedia, or a cultural genome project, where we basically explicate and codify the success principles of the cultures around the world and make it accessible for everyone and make it possible to combine those success principles to come up with new solutions to local problems by combining the best ideas around the world. This is how I imagine we would actually address the challenges of the future and come up with a collaborative paradigm in a highly networked world, a new kind of culture that we could actually start now. And that means we're basically at a tipping point where the old systems are failing. We need to find new ways of organizing ourselves and organizing the world and our interaction with nature, other people, other cultures. And that is something that we should now engage in. And for this, we need to leave old ways of thinking behind us. We have to break the matrix, and that will bring us the next civilization. Thank you.